still getting used to Twitch. So for those of you that might be watching this either live or watching this video on demand, still getting used to Twitch, which is why I don't have any of the fancy overlays or any of that other stuff set up yet. I kind of told myself that if I can stick with doing this every week for a few weeks, then I'll invest some time into trying to figure out how to make it cooler. Hey, I've got somebody watching. Sweet, that means I'm not necessarily here all by myself. Hey, Jim Goose. I know who that is, by the way, but I will keep that to myself. So I'm experimenting some today, I think, with GitHub Actions and Concurrency, which is a new, well, it's not new, it came out about in May, I think, but it's a keyword that you can use to control when workflow files are going to kick off. So, for example, usually when you're deploying to, say, production, you only want one deployment to happen at a particular time. And so you would want to make sure that if I did a pull request that was approved and it started the deployment to production, if I then had a second pull request approved, you would not want that second pull request to also start deploying to production at the same time. You would want the first one to finish before the next one ran. Another good example of concurrency might be, let's say you have a branch protection rule on your branch where whenever you create a pull request, you do a build and you run a series of tests. But that build and that series of tests could take a long time to complete. Now, if I make another change to that branch and commit it and push it, then that's going to also trigger another workflow to run. And we wouldn't necessarily want that to happen. Instead, what we would want is the long-running workflow to stop and our next workflow to kick off, because that would save us time, that would save us build minutes, etc. So we didn't have a good way to do that before this concurrency keyword. So now we're going to dive into that some and see how we can use this concurrency keyword and how it might work. Now, I'm still learning about this whole concurrency keyword. In fact, let's go find the docs. Hold on a second. GitHub Actions, docs. Let's go find the documentation. And if you've not looked at the GitHub documentation, the GitHub documentation on Actions especially is just great. Come on. Okay, don't. And so if we go to reference and we go to workflow syntax, this is where you can see all the information around what can go into the YAML file for GitHub Actions. And you'll notice that we've got a concurrency keyword here. And then we've also got concurrency under jobs. So we have the ability with the concurrency keyword to configure this at the workflow level, which means it applies to the entire workflow, or the job level, which means it only applies to a specific job in that workflow. So what I thought we'd do in this particular stream is go experiment with that a little bit and see how it might work at the workflow level, and then if we have time, we'll also see how it might work at the job level. So let's come back over. Let's move this out of the way for now. And I've got a repository that I'm using for all my experiments right now. So I'll link to that in the chat. And this is a public repository. So my MickeyGousset.org, this is a public repository. So you're able to go look at that repository. You're able to fork it. You're able to, do whatever you want. This is where, when I'm experimenting with things that I don't really understand, this is where I'm going to play with it. So it's kind of a sandbox. So it's, quality may vary, I guess. So just be aware of that. I'm also looking at what's available just to public repositories right now. I'm trying, because there is some stuff that's available to, if you're running, say, GitHub Enterprise versus just using regular github.com. So I'm kind of sticking with just the features that are available on github.com for public repositories. So here is my repository. Now I've took the liberty, I've been experimenting with this some today, so I took the liberty of going ahead and creating a workflow file that to get us started. So I've got my main branch, and let me go into settings before we get started, and let's go to branches. I'm going to get rid of a branch protection rule that I had here earlier because I don't need it. Hey, I need to know my password. Hold on one second. But you don't need to know my password. Give me 1 second here. And if you don't use a password manager, you should use a password manager, because password managers are amazing. And it means I don't have to remember everything. All right, so I whacked that branch protection rule. Good job, Mickey. So let's go back to our main repository, and I'm going to go to my .github workflows folder, because remember, any GitHub action workflows that you create have to live in this .github/workflows folder. It's where they have to live. So if I go in that folder, you can see I've created a particular workflow file for me called concurrency-pr.yaml. Now, my scenario is this. I want to trigger this workflow file whenever I create a pull request. So that means to the main branch. So that means anytime I create a pull request targeting the main branch, or I do a commit to a branch that has an open pull request, this workflow file is going to run. And if we just look at the basic workflow file, hold on 1 second. Let me see if I can do something to make this a little bit fancier. Bear with me. Let's see if this will work. So, let's see. I'm waiting to see if it zooms in. Ah, look at that, beautiful. So, this is just a standard GitHub Actions workflow file. So, I've got a name. Ooh, I've misspelled the name, so we'll have to fix that. So that's the display name. It's triggering on lines 4 through 6 on a pull request to the main branch. So this will be triggered anytime there's a pull request to the main branch, or anytime there is a commit made to a branch that has an open pull request to the main branch. Now you'll notice I've got lines 8 through 11 commented out right now. We'll come back to that as we start to add in the concurrency. And then if we look at the job itself, in the job section, I've got one job. Build and test on PRs is that job. It runs on Ubuntu latest, and it's got some steps. I'm outputting the head_ref, the github.head_ref, which is essentially just the branch name. And I was just doing that. In this case, I was doing it because I was just testing something, but I've left it there because it doesn't hurt anything. And then I'm simulating doing a build and a test that are a little bit long running. So I've got a step here that builds the code. And again, I don't have any actual code that I'm building right now. So I just echo out starting the code build. I put a wait for 2 minutes, and then I echo out finishing the code build. And then I have the same thing with a test. I have a step called test the code, which basically does a 2-minute wait. And I put these waits in here just to be able to simulate long-running workflows, so I could see what happens when I started trying to use this concurrency. So what happens right now if we create a pull request, or if we make a change or create a pull request, and then the workflow should kick off. And then if we do another commit to that, what happens? Let's go find out. So we're going to come back over to code, and I'm going to edit my README file. And we can blow this up a little bit. And we're going to call, we'll just say this is testing 1. And we're going to say my commit message is testing 1. And we're going to create a new branch for this commit. And we'll call this branch Mickey/testing1. So we're going to, and then we're going to propose that change, which takes us to creating a pull request. So we're going to propose that change. And I'm going to say, change for testing 1. You'll notice that we are going from our branch to the main branch, and we're going to say create pull request. Now in just a moment, we'll see it should pop up here that it's going to run that workflow because that workflow is targeting a branch. And if I come out here to Actions, then I can see there's my change for testing 1, and it is currently running. If we drill down into it, we can see here's the GitHub action or workflow. We can see the individual steps, and right now it is on the build the code step, 16 seconds, 20 seconds into its 2-minute wait on the quote build that we're doing. Now, if I come back to that branch, so I switch to that branch, and let's say I edit that README file again. And in this case, we'll add another line and we'll say this is testing 1.1. And we're going to commit directly to that branch. Now, because we have an open pull request, when we push this to that branch, it's going to automatically be included in the pull request. So I'm going to click Commit Changes. And if we come back and look at the pull request, then we can see that both our commits are part of that pull request, and they both have started workflows. So you can see that because we made another commit to that pull request, it started another version of that workflow using that commit for its build and its test. Now imagine that this branch has a lot of turnover, a lot of volume, a lot of changes being made to it. 15, 20 commits being pushed, changes maybe that get pushed into this pull request. Then at that point, you're kicking off this action workflow 15, 20 times. Now, if each of those workflows takes 4 minutes to run, then you're using almost an hour and a half of your build time if you're using hosted runners. And in reality, you may not need that. In reality, you may just want to have the latest commit be what's running. Or it could be that you want to queue up these changes so that the first commit finishes before the next one would run. Well, that's where the concurrency keyword comes in. So let's cancel these. And just because we can, we'll come out here and we'll cancel this pull request as well. So we're going to close the pull request and I'm going to whack the branch. And that's just me cleaning up. I didn't have to necessarily do that, but that's just me cleaning up. So let's go back to our code. I'm playing with a window over here where I can try to see if there's anyone in chat. Oh, that's cool. Okay. I'm getting used to Twitch. Working on it. So we've saw what happened right now with the way Actions works now. If we have an open pull request and we do another commit, that workflow that runs on a PR is going to trigger a second version of it to run. And that may not be what we want. So instead, we want to look at that concurrency keyword. So if we pull up the docs on the concurrency, first thing we'll notice, and for those of you joining, thank you for joining. Be aware that I am figuring out some of this concurrency stuff as we go, so you can experiment along with me. If you don't know me, I am Mickey Gusay. I'm a DevOps architect at GitHub, and I'm also experimenting with this whole Twitch thing. So feel free to ask questions in the chat. If there's anything, if you have any specific questions, even if it's not necessarily on the topic, I'll be happy to try to help. So as we saw before, concurrency can be defined at two levels. It can be defined at the job level, or it can be defined at the workflow level. Now, we are going to try and do this initially here at the workflow level because that's what makes sense for us, right? We have this PR that runs whenever we, or this workflow that runs whenever we create a PR or issue a commit to an existing PR, and we want to use concurrency to try to limit how things run. So if you look at the docs, remember now this is in beta, so how all this stuff works is completely subject to change. So if you're watching this as a video on demand or on my YouTube channel at some point, then realize that it is September 12th, and how this ultimately works out when it comes out of beta could be a little bit different. So concurrency ensures that only a single job or workflow using the same concurrency group will run at a time. Now, our concurrency group can be any string or an expression. So you could have a static string defining your concurrency group. You could also have an expression such as string dash branch name, or whatever we could get out of the GitHub context object. And if you don't know how to see what's in the GitHub context object, there's a couple of ways. One is you can actually look in the documentation, and the documentation will tell you, or you can actually output that to the build log or to the run log and be able to see the specific context information for your particular run. If you don't know how to do that, I'll be happy to show you that as well. Now, the expression, since we're defining this, remember, at the workflow level, at the top level, the expression can only, if we make an expression, if we don't make a static string, then the expression can only be use the GitHub context. And there are multiple context objects out there, but the expression can only use the GitHub context object because honestly, at the time that the workflow gets started, the GitHub context object is the only object that's there. So when a concurrent workflow is queued, if another workflow using the same concurrency group, using that string, is in progress, then the queued job gets made pending. And this is interesting. Any previous pending jobs get canceled. And if we want to cancel the currently running job workflow, we can use another keyword, cancel in progress. So let's work our ways into this, right? Let's work our way into this. We're going to start off by just adding a group, just a static name for a group. So if we come back over to our workflow file and we edit it, one of the things I'm going to do is fix my typo. But at the workflow level, so above, before we start defining any jobs, what we want to do is specify the keyword concurrency. Now, if you're ever curious what your options are that you can type in a particular spot when you're using the web editor, you can hit Control Space and it will show you the options that are available for you to type. Now we're going to use the keyword concurrency. You'll notice that it has all these red squiggles underneath it, and that's because we haven't we have syntax issues because we haven't defined a group name yet. So we're going to define a group name. And that group name is going to be build and test. So that's going to be our group name. These other things are commented out right now. That's why they're gray. And so this is going to be our concurrency group name. So that means the concurrency rules are going to apply to any workflow that uses this group name. And I'm betting that's going to be true whether it's the same workflow file or a different workflow file. You know what? I have not tried that yet. So let's make a note of things that we might want to try. Hold on one second. Let me get something open here so we can keep track. So, things to try. Using the same concurrency, can't spell, you'll forgive me, group name in two different workflow files. So we'll come back to that later. But what we have done is we've set the concurrency for this workflow file to be build and test, and we've set it at the workflow level. So I'm going to commit this back to the main branch real quick. Added concurrency group and commit those changes back so we can use them. All right, so now we have a workflow file that has a concurrency group of build and test. Okay, let's go back to our code. Let's go edit our README. And we're gonna say, we'll call this concurrency test 1. Give it a commit message. We're gonna create a branch for this. So the branch will be Mickey/concurrency test 1. And we're gonna go propose this as a change. Okay, so we're proposing this as a change. And I'm going to create the pull request. Now when we create the pull request, we'll see in just a moment it'll pop up here saying it's going to run the action, which we expect. And we come back to the Actions tab, and we can see that our workflow has kicked off as we would expect it to, because it's triggering off of a pull request to main. Let's wait till this thing gets started and then we'll go make another change. And let's do a quick little refresh. All right, so it's waiting on a runner to come online, so it'll come up with one here in just a second. And of course, if we look on the Actions tab, we've only got one instance of this thing running right now. It's currently queued. This is, you know, live demos. Sometimes you don't have a runner right when you need it. Could also have gotten confused, in which case, if it doesn't start up here in a second, we will cancel it and try it again. All right, so let's cancel this workflow out. Oh, did it cancel? Or is it actually running? Okay, so it's running. It just wasn't refreshing for us. That's okay. So we have the workflow running. So now if we come back out to our code and we change to that branch that we were working on, and we make an edit, and we'll call this edit test 2, concurrency test 2. We'll commit that to the branch, which adds it to the PR. And you'll notice So I've confused things a little bit. So let's take a step back. I did cancel that workflow on my own. All right, it did finally cancel that workflow. So this cancellation you're seeing here is the one that I actually made it do. So this is the change that we just made with test 2, and it is currently running. So let's come back and go to that branch again and make a change, and we'll call it test 3, and we'll just make the commit message test 3. Commit to that branch, which adds it to the pull request. You can see here that it added it to the pull request, but it didn't start it. And if we go to Actions and look, you'll notice it is in a pending state. And if we drill down into it, then we can see it's in a pending state because it's waiting on the concurrency PR to complete before running. So it's waiting on the previous version, that version that was already running, to complete before it's running. So it did exactly what we expected it to. Because there was a version of it running that has that same group name, it put this version into a pending state. So let's go make another change on that same branch. Switch to that branch. And we'll call this change test 4. Now if we make another change on that same branch, it's going to add that change to the pull request. So there's our test 4, so we see all of our commits on this. But now if we come and look at the actions, you'll notice that this change has now been canceled, and the latest commit that we just pushed has gone into a pending state. But this one, which was in a pending state, is now canceled. And that's because, remember, the documentation states when a concurrent job or workflow is queued, if another one using the same group name is in progress, then it goes into pending. Any previous workflows in the concurrency group are canceled. So Jim Goose asks, what's the benefit of concurrency? So there's a couple of areas where it's important. The benefit is to be able to control in more detail when a workflow or a job runs. As you saw before I added in the concurrency keyword, when I made that change and I created the pull request, it kicked off the workflow. Let's say that workflow file is doing a build, building the code, and then running a whole bunch of tests that take 30 minutes to run. When I made that second commit and pushed it, it triggered the same workflow file to run, and that workflow file immediately started running. So that means I now have two workflow files running at the same time off of the same PR using a whole bunch of build minutes, which in that instance may not make a lot of sense, because it might make more sense to figure out a way to stop that first workflow file so that the second one can then run, and we're conserving our build minutes, which ultimately can cost us money. A better example, or another example, not necessarily better, but another example would be we've got a workflow that deploys to production, and we only want to deploy the latest code to production. In the instance before we added the concurrency, we created that first pull request, and let's say that was actually a push to main. That does a deployment to production, and that starts the deployment. So it's running. Then we created that second commit, or say we do another push to main, which triggers the workflow file to run again. Now we have two workflow files running at the same time trying to push to production. And we have no guarantee which one's going to win. So it could be that we end up writing older code to production than we mean to. So in the push to production, what we'd actually want to happen is this first workflow to finish, then the next workflow to run and push to production. So it's all about controlling when stuff is going to actually run. So what we proved out over here with our pull request and our concurrency keyword is that when we did kick off a workflow that had the same group name, that same keyword, that same group name, then it did exactly what we expected. It put it into a pending state, or it canceled the pending one of the previous pending one and made the current, the latest one we just did pending. So it worked the way we expected it to. Now this also means that if we have multiple pull requests, we keep that static name there, we could have some collisions, because that would mean that whenever this remember, because when this workflow file kicks off, it looks for that keyword name to determine what it's supposed to do. But let's take this, okay, so rather than having it go into a pending state and wait until the previous one is finished, let's go with the scenario I was talking about with a pull request and long-running builds and tests. What we want to happen is, if there's a new commit to that pull request, we just want it to stop the previous workflow that was running and run this workflow on our latest commit. So let's see, are you finished yet? You've got to be close. Oh, not really. So I'm going to cancel this workflow out just because I can. And while that's canceling out, we're going to come back over to our code and to our workflows. Go back to our concurrency workflow. And we're going to add in this second parameter that you can provide. And that parameter is cancel in progress. And that can be set to true or false. Now, by setting this to true, what should happen is if we have an existing workflow running that uses that group name, and we start up a new workflow using that group name, what we should see happen is it should cancel the previous one and just go with the new one. So let's save these changes. We'll just push that to main, that's fine. And now let's go back, and if we look, we don't currently have anything running. So let's go back to our code. We can go back to that branch. We can keep working with that branch for now because we have the open pull request. So rather than creating a bunch of new pull requests, we can just keep using that same pull request for now. I will edit my trusty README file, and we'll call this test 5. And we'll commit to that branch. And when we commit to that branch, if we go to the pull request, we can see there's test 5, and it has started up a workflow. Sweet. As we would expect. Again, haven't showed you anything I haven't been showing you, but it makes sense. So if we come back over to code now, let's make a change to our branch. So let's switch to our branch. Let's make a change. And we'll call this test 6. We'll commit that to the same branch. Now previously, it would put this workflow into a pending state. and the other one would stay in progress. And that's what initially happens, right? It goes into a pending state, and this one goes to in progress. But let's just keep watching for a second and see what happens. Because we did say that cancel in progress is true, and bam, did you see what happened? It canceled it, and it started up the latest one, which is exactly what we expected to happen. And if we look at the one that was canceled, then we can see there's even a message that tells us this was canceled on a higher priority waiting request for build and test. And that's because we had that cancel, we set that value to true in the workflow file. Now, what happens though? So right now, we have this running. Concurrency Test 1 change pull request has this action running against it. What if we come back to our code and we edit this file off the main branch and we just say, I wonder what will happen. And we're going to make the commit message say, I wonder what will happen. And we're going to commit this to a new branch. So we're going to commit this to the Mickey I wonder what will happen branch. And it's going to create a pull request called I wonder what will happen. So what do you think is going to happen? I'm going to create this pull request. So what do you think is going to happen? Any thoughts? I'll give the chat a second if they want to try to guess what they think is going to happen. Well, there's my commit. I wonder what will happen. And it looks like it has started up an action, which is what we would expect because we created that pull request. So therefore, it triggered the workflow that's looking for pull requests that are targeting main. And if I go to actions, it canceled the workflow that was running on the first pull request and allowed the workflow that was triggered by the second pull request to take precedence. And that's because even though it's two different pull requests, in the workflow file itself, we're using the same group name. So even though we have two different pull requests, we're still using the same group name. And so therefore, the rules are going to apply. It's going to go, oh, you've got a workflow running with this group name already, and you said cancel in progress. So therefore, we're going to cancel on the first pull request and just run the workflow on the second pull request. So that leads me to believe through process of deduction that this, using the same concurrency group name in two different workflow files, will still cause the exact same thing to happen. We've basically simulated that using two different pull requests, but if you have the same concurrency group name in two different workflow files, you're still going to have that clash. Now, what would happen if we didn't have the cancel in progress, or if we had that set to false? Then it would do that whole pending thing where it would cancel one and still run the other one in a pending state. But what you're ultimately running into is a bunch of weird clashing that you don't want to happen. And the clashing is happening because that group name, that build and test group name, are the same. So how do we get around that? Well, you can probably already see how we get around that. But we get around that by making the group name dynamic. So in this case, I'm calling this group name tests on PR, and then I'm using this variable name. Now, what we're doing here is, remember, because we're running this for the entire workflow file at this point, what we're doing here is we're saying, hey, GitHub context. So, and the GitHub context object is an object that's available when the workflow first kicks off that has a bunch of stuff around the workflow. We're saying, hey, GitHub context, give me the branch name. And I get the branch name by using the .head_ref variable that's in the GitHub context. Let's do this. Hold on one second. Let me find an example. Now, if you want to see what's in the GitHub context object, you can go look in the documentation, but we're going to also modify our code here to show us what's in the GitHub context object. And what this code is doing is it says we're creating an environment variable that's local to this step that we're just going to call GitHub_context. And then we're using a to.json file to take the GitHub context object and convert it to JSON. And then we're just outputting that JSON. So this gives us, for this particular run of the workflow, information around the context of this workflow run. So what we've done is we're outputting the GitHub context, and we've also changed the group name to where it's going to look for, instead of a static name, the name's going to be based off of the the branch name. So let's come back over here. Let's see if we still have any actions. Oh, thank you for saving. Let's save our changes first. So we'll update our workflow file. If we come back over to actions, let's see if we have anything running. Okay, everything's finished. All right, everything looks great. So, remember previously we made a commit to the first PR. It started running on the workflow started running against that commit on the first PR. Then we made a change to the second PR, and because of that cancel in progress, it stopped the one on the first PR because the group names were the same. Now, in theory, the group name should be different. So let's see if that's the case. So I'm going to come to this branch first. Let's make a change. We'll call this test 7. Remember, we still have an open PR, so I don't have to go recreate a pull request. I'm just going to commit to that branch. And if we go look at, we can see there's the test 7, and we can see that the action is running, or it's queued up now, and now it's in progress. So now if we go back to our code and we go to workflows, oh no, sorry. We go back to our code and we change our branch to be the I wonder what will happen branch, and we make a change. I still wonder, and we'll put that in the commit message as well. And I commit directly to that branch, click commit, and we go to that pull request, and we can see there's the I still wonder, and we can see that it has started up an action. And if we come over here and look, then now you'll notice that both workflows are in progress and they're both running. Now, if I did come back over to, say, the I wonder what will happen branch, and I made another change, then what we should see after a moment is we'll see another workflow pop up here. There it is. And we should see that one cancel and this one go in progress if we give it just a moment. because they will match because their branch names are the same. And as you can see, that's exactly what happened. Sweet. And if we come in and look at this run, I told you we could output the GitHub context object, right? Here's us outputting just the branch name. But remember, we took that GitHub context object and we turned it into JSON. So here is the information for the GitHub context object. So it gives us, job name, repository name, the run ID, which is the run ID of the workflow, who the actor is, event information that kicked this thing off, pull request information along with all the information related back to the pull requests, all kind of URLs and other things. The GitHub context object has a ton of information in it that you can use to help with your automations, because you can come in here and grab any of these URLs and hit the REST APIs and be able to pull stuff back and do a variety of different things. All right. So that all worked about how we expected it to. It's always good when things work the way you expect them to. So that was us being able to control when an entire workflow ran. But we can also define this thing at the job level as well. So let's think about this. What would be a good example of possibly wanting to do this at the job level? Let's talk about doing this from the point of view of doing a deployment. So when we do a push to main, so like when a pull request is approved and we push that code to main. Let's say on a push to main, here, let me make this a little bit bigger. So on a push to main, we want the following to happen. We want to build the code, deploy to prod. Okay? So again, we're simplifying, right? We'd probably have tests and other stuff that happens as well. Oh wait, there's a question. What about if you wanted to run 2 requests from the same branch? Would say no for cancel in progress. So you can't have 2 pull requests on the same branch. That's just a function of Git and GitHub. When you have an open pull request against a branch, then any other commits you make are gonna go directly into that pull request. So you can't have 2 different pull requests against the same branch. Does that make sense? Okay, so while we're waiting to see whether that made sense or not, cool, thanks. So we're going to simplify on a push to main. We want to build our code and deploy to prod. Now this is where we run into that potential, well, what if we have multiple branches that are pushing to main? That's where we could be deploying the wrong code to prod at the wrong time. And you can think of that, if you'll think back to when we had the 2 pull requests, or when we didn't have the concurrency in there and we did the 2 commits to the branch, then it kicked off 2 versions of the workflow. We'd see the same kind of thing on a push to main. Let's go try that out. So let's come back to code. And let's go to workflows. And what we're going to do is we're going to cheat a little bit. We're going to grab all this. And then I'm going to come back to my workflows folder and I'm going to add a new file. And we're going to call this push to main.yaml. We're going to change the trigger to be push to main, or the name to be push to main. And we're going to change the trigger here's what we're going to do first. We're just going to save it for now. And the reason we're going to save it is so then I can go ahead and get to the workflow editor that's available, which gives me a little bit extra IntelliSense. So we'll commit this directly to the No, we won't, because when we commit this to the main branch, it's going to automatically kick it off. No, it's not. It's not going to kick it off because we don't have a pull request yet. So that's fine. So we're going to commit this file. So now, if we go into this file and we say, hey, let's edit. And you may be able to hear my cats in the background. That's because they are really loud. And in fact, I'll introduce you to one. Hold on. This is Todd. Todd is really big and really fat. There he is. But he's lovable. And he's also loud. So, back to what we were trying to do, which is we want to create a workflow that does our deployment when we do a push to main. So you can see I have the option to do push. And I can do it on a particular branch. So just like with pull request, we want to trigger on main. Now I could also write this as main. So we are going to, on a push to the main branch, we want this to trigger. Let's just let's get rid of all concurrency right now. So we're going to comment out all concurrency right now. And we've got all concurrency commented out, so that's fine. And down here, let's simulate this. This is going to be build and deploy. So this we'll change the job name to be build and deploy. I'm not going to worry about outputting the head ref at this point. I'm not going to worry about GitHub context at this point. What we are going to do is build the code and then deploy the code. And remember, for anybody that's just joining me, hi, we're messing around with GitHub Actions and concurrency. But feel free to ask any questions you might have around GitHub Actions or GitHub. I'm a DevOps architect at GitHub. I'll be happy to try to answer any questions that I can. I'm learning about this concurrency stuff kind of with you, so that's why we're just kind of experimenting. So this is going to be deploy the code. And we're going to say, we'll call this start code deploy, end code deploy. Now we're simulating. Am I still streaming? Woohoo, I'm back. That was weird. I had a glitch. I think I'm back. Sorry about that. Looks like I'm back. So I'm going to assume I'm back. OBS says I'm still streaming. Sweet. All right, so let's go see if it actually kept my change or not. And of course it did not. So we got to do all that again. So let's make this quick. Let's make this quick. Let's come out here. Let's change this to be push to the main branch. And we wanted to make all this concurrency go away for right now, because I just wanted to show what happened with before we had concurrency. What were some of the problems we could... All right, I got a text saying that the stream is not playing. All right, let's try this. We're going to stop it and come back. So, okay, so I have stopped my stream and started my stream. In theory, everything looks great. Hopefully y'all can see me. Hopefully I'm streaming. Okay, sorry for the technical difficulties. Okay. Well, let's try this again. So we want this to run on a push to main. We don't want to have any concurrency. We wanted to change this to be build and deploy. We're going to change the name to be build and deploy. We're going to get rid of a couple of steps that we don't need. And we're going to have this step here that builds our code, and then this step that deploys our code. Now, I'm going to show you what happens before we had concurrency. So let me commit this change. Now, right now we have 2 open pull requests. And we have no actions that are currently running. I had a couple of people that were watching, but I guess in my restart I lost them. That's disappointing. You can see the push to main, that we've got this push to main is running because we made that change to the file, to the workflow file, and pushed it directly to main, and therefore it started off this push to main. So let's cancel that one for now. But so we're not going to have any workflow files that are running. So what we want is to go, let's approve let's merge our pull requests. Let's approve them and merge them in. Let's refresh this, make sure we're at a clean state with no workflow files running. So we come back to our pull request. And you know what? This pull request, we're ready to merge it in. So I'm going to go into the pull request. I'm going to, we're probably going to encounter some conflicts, unfortunately, because we're modifying all the same file. But if I merge this pull request and I confirm the merge, and then I delete the branch, just because I can, then it's going to kick off that action. Now, unfortunately, this isn't going to be as clean as I wanted, because, already it is actually, because if I come down here, you can see I've got the conflicting files. So let's see. We're going to keep my changes. Get rid of the other changes. And now I've started that, I've merged that pull request. Now where this is really going to get kind of interesting is you'll see that here is the push to main and here is the push to main. So now both of those pull requests are pushing to main at the same time. And we don't want that. We don't want multiple workflows pushing to main at the same time. We want to be able to control that in a little bit better, more controlled manner. We want to be able to make sure that things go into main in the order we want them to go into. And of course, because we had to make another change because we had to modify our merge conflicts, we have a commit that triggered the workflow on the PR as well. But this is why we need concurrency right here, because this workflow and this workflow are trying to commit or trying to deploy to production at the same time. And we don't want that to happen. It doesn't matter that they're on the same branches, different branches. We still are probably only going to have one workflow file that does the actual deployment to production, and therefore we want to be able to control that. So that's where we're back to using that concurrency. So let's cancel all these just to clean things up a little bit. So let's see how we can use concurrency then to help us with the deployments. Now, here's the thing, and this is what I'm curious about. If you'll remember, we can define concurrency at both the workflow level and the job level. And previously, we've been defining it at the workflow level. But I'm thinking that it's okay for the build job to run. Even if we've got multiple deployment, even if we've got multiple versions of this workflow file running, it's okay for the build job to run. Go ahead and build the code, who cares? But the deploy job, we want to wait if there's any other versions of that deploy job running. So let's try modifying this push to main to add concurrency to the deploy job. Oh, that's a step. Oh, that's not going to work. Oh, but it would. Okay, let's change this up. Because chances are you're going to have a build job that just does the build. In most cases. And then you're going to have a deploy job that does the deployment. Now, we don't want the deploy job to run if the build job doesn't complete successfully. So now we have two different jobs that are running. All right? So we're going to what will happen by default, if I ran this workflow file, both these jobs would run at the same time. Build would start and deploy would start at the same time. I don't want build and deploy to start at the same time. So instead, what I'm going to do is I'm going to say needs build. So this says the deploy job needs the build job to finish successfully before the deploy job can run. And on top of that, we only want this deploy job to run if there aren't any other versions of this deploy job running. So we want to add the concurrency group, and we will call this my deploy. So what we now have is a workflow file that's going to execute anytime there is a push to main. That workflow file has two jobs in it. The first job tries to build the code. I'm just cleaning up my code a little bit. And I don't think I've got my spacing right. Hold on. Let's see. YAML is white space sensitive. Okay, so that was good. And then the first job is the build job, and then once it completes successfully, the deploy job is going to kick off. Now we want to make sure we don't have that issue of multiple deploy jobs running at the same time. So we've added the concurrency to the deploy job. Now we haven't tried this before, right? We were doing this at the workflow level. So I'm curious what it's going to look like at the job level here. So let's commit this. And we're pushing this to main, which of course is going to immediately kick it off. So we're going to stop it. And what we're going to do is come back out to our main branch, and we're going to make a change. And we're going to say this is deploy 1. Commit this to deploy 1. We're going to make a new branch. We'll call it Mickey/deploy 1. And we're going to propose this in a pull request. Let's come out here to Actions. Let's go to our run that runs on a PR right now, and we're going to disable that so that we don't have to deal with it running right now. And if we go back to our code, we're going to create a pull request for the deploy 1. So we'll call it deploy 1, and we're going to say create a pull request. So this is going to create a pull request. Since we're not going to run that workflow file, it's going to say, hey, we can automatically merge it. So we're going to confirm the merge. And back over here on the Actions tab, we're going to see we've got a build job that's going to run and then a deploy job. And right now the build job is running. So let's come back over to our code. Let's make another change. We'll add deploy 2. We'll call this deploy 2. We're going to commit this to Mickey/deploy 2. And we're going to propose this change. We're going to create that pull request. And we're going to merge that pull request. So now we've done 2 pushes to main. So what we should see are both of our workflows should initially start running. see if I can figure out a way to make this, be able to see this side by side. So that's 16. So here's the first one, and it's run. Oh no, that's the Word doc. Sorry. It's running. And here's the second one. And the build is running. So in just a moment here, we should see it's about a minute behind. So in just a moment here, we should see this one, the build finishes, and the deploy starts. So now the deploy is running. Now, over here, the build should finish in about 40 seconds. Now, what I'm interested to see, if you'll remember, we turned on the concurrency. Now, we didn't say cancel, so the job shouldn't cancel, but it should go into a pending state. So I'll be curious to see, and let's go ahead and open up the Actions tab in a new tab to see what we'll see there as well. But you can see that deployment in the first pull request is still running. So let's see what we're going to see in the second. So it stops, and the second goes into a pending state. This workflow is waiting on a deploy to complete before running. So that's exactly what we wanted it to happen. Now, what do we see on the main Actions tab? It shows it in a pending state. So if I could get a change in time, then it should cancel that one out. I don't know if I can do it, but let's try it. So if I go to deploy to, and I make a quick change, commit it directly to the branch, then that should have pushed it back to the PR. Oh, there's no PR. We closed the PR. So we'd have to create a new pull request for it, and I'm out of time. Yeah, so I'm out of time. I didn't make it. So in theory, what we should see is now it was impending, and now it's no longer impending. And it's deploying. So that works the way we expect it to as well. And it works basically the same way that we saw that the workflows, setting at the workflow level worked. It just worked, it set the job at the pending level. So I'm assuming that if I'd had more time, it could have created another push to main. But here's the timing thing. If I'd created another push to main, it's still got to do the build before the deploy. And if the deploy hadn't... So it would still have to be in a pending state for the new push to main when it hit that deploy job to go, oh, it's still in a pending state. But this is one of those instances where you could use the cancel on if true, which would cancel the previous deployment job, though that could be kind of nasty if you canceled a deployment job in the middle of deployment, something to think about. Or at the very least, even if you don't cancel, you're queuing up the deployment so that they will run one after the other. Okay. All right, this is making sense. And I think that's really about all we can show with concurrency. That's just about how it works. All right. So that's kind of what I wanted to stream tonight. Kind of happy with how that went. I'm sorry about the glitch. I will get this turned into a video on demand and see if I can merge those two clips together or something and get them posted up on the stream. Any last questions? Otherwise, I'm probably going to call it a night and see if I can work on getting this video posted. I do appreciate your time. I'm kind of having fun doing this. It's kind of fun to experiment around. And I do have a video about concurrency going up on my YouTube channel tomorrow as well. If I get it edited tonight, we'll see. If not tomorrow, then Tuesday. But I'm kind of enjoying this Twitch thing. If you like it, you know, let me know. Feel free to subscribe. Feel free to leave me some comments. I'm going to keep trying to do this every Sunday night until I either can't or find something else. I am looking for topics. So if you've got a specific topic that you're interested in seeing me stream about around GitHub, then feel free to drop me a line. You can find me on Twitter at Mickey_Gousset. You can send me an email at mickeygousset@github.com. mickeygousset.com is my website. So if you got any comments or anything you would like to see me try to cover during these streams, hit me up. I'll be happy to try to do it. All right, everybody have a good night.